പൊട്ടിയോ?
വീഡിയോ കാണണ്ട, നമ്മുടെ വീഡിയോ ഇത് സ്ലാഷ് ചെയ്യാം.
All right.
If you click here, what happens? If you click
What I going on? Sebab dia dah masuk. Dia tak ada. Sudah. Sudah ada banyak orang tu.
Numeric meeting password, followed by pound.
Tak ada. Keluar Leli.
Hi, morning everyone. This is William from PIAM. Yeah.
Morning.
Okay. Thank you for logging in early. Our webinar will start at 10:30. The reason why we open up earlier is for you to test your audio and visual. So we will start right on time at 10:30. Thank you.
Zahidah?
Tak ada pun. Tak nanya, tak boleh. Okay, tak?
Yeah, one more thing. May I request everyone to mute your mic because we do not want we want a smooth session. We do not want any disruption. So I'll touch on this again later during the housekeeping. But meanwhile, can you kindly mute your microphone? Thank you.
Tadi
Tak ada lah.
So some states doing better than others, some states going backwards, in some cases going up again. I know we've all experienced that across Asia over the last 5 to 6 months in particular. So yeah, just a quick.
Can you listen dulu? Just hear lah, see whether you can it help?
Morning. For those who have just joined us, we'll start in 10 minutes time, right at 10:30 sharp. So meanwhile, you may want to use this opportunity to test your visual and audio connectivity. Thank you.
Test.
Hello. Dia tak dengar. Dia tak dengar. I dah mute tapi kenapa still dengar?
Hello.
Tak dengar suara.
So, okay, I am connected in. So, just a blank screen, no one.
Thank you, Fu. Yes, we are about to start in 3 minutes time. We'll start at 10:30 sharp. Thank you. Okay, good morning, everyone. This is William from PIAM. I have my colleagues, Kwan, Shafa, Fariza, Shanti with me. Now, of course, our distinguished speakers, Mr. Lu and Mr. Kim from the Institution of Engineers Malaysia. Thank you for joining our guideline to flood abatement webinar this morning. And of course, a special thanks to IEM for making this possible. Now, I noticed that we have slightly more than 120 participants online right now. We have, by right, we should have more than 150 participants. So I guess participants are still logging in at this point of time. Now, to ensure that we have a smooth and orderly session, let's have some common understanding here. That is what I'm about to say. Could you kindly mute your microphone? Okay. So now, during the session, you can actually post questions using the chat box anytime during the presentation. However, the questions will only be answered after the presentation. Now, rest assured, the presentation slides will be available for downloading from PIAM website after the webinar. I guess as early as this afternoon, if not tomorrow morning. So with that, maybe just a brief introduction of our speakers this morning. We have engineer Mr. Lu Chi-kin. He's the chairman and founding member of the Disaster Risk Reduction Advisory Board, a senior consultant with 20 years of engineering experience, particularly on natural hazard assessment. And our second speaker for today, engineer Kim Kek-seong. He's an active member of the IEM Membership Application Board, Disaster Risk Reduction Advisory Board, and also a member of the training board. Now, with that, I would like to hand over the floor to Mr. Lu. Over to you, Mr. Lu.
Hello, good morning, everybody.
Yeah, morning.
Okay, thank you, William, for the introduction. I am Engineer Lu, the chairman of the Disaster Risk Reduction Advisory Board in Institution of Engineers Malaysia. So today I will go through my first session is to talk about the guidelines of the flood abatement equipment. And so some of you may be looking at the title and wondering, is there a typo mistake in that or not? And so actually the guidelines is saying is guideline of destination, testing, and documentation. So basically what this document is about is that it's actually designating what is flood abatement equipment. So it's actually not a design standard. And this morning, what I'm going to talk about, this particular guideline here is not talking about the design specifics, but rather actually what should qualify as a flood abatement equipment. So let me just run through, something that we very often, see in Malaysia. Flooding, these are news. Flooding in car parks, flooding in tunnels, underpass. Flooding also happens inside buildings, all around Malaysia. We do have many different areas that's been flooded for various reasons. Flooding also happen in very unexpected areas, like Middle East. We always assume that, well, it's in the desert, doesn't rain. Yeah, but when it rains, you get flooding. Flooding can also occur when the water is coming from sea. So like in this is in Cork, Ireland, you got flooded because of the high tide. So these are some of the pictures, from various places that you can see. When flooding happens, it causes a lot of inconvenience to people. There's also caused a lot of economic losses. It's where, being insurance people here, this group here, we're very interested in the damaged goods that's caused by flooding, interruption to utilities, infrastructure. So when flooding happens, production machines goes down, gets damaged. There's also interruption of utilities, electrical distribution, because you have transformers in the yard. And the picture on the right bottom corner, it's not very clear, but actually it's a flooded sewage treatment plant. So when a sewage treatment plant is flooded, basically an entire community can go down because our sewage water can't go anywhere. So what is flooding? So this is a very simple definition, but I'm sure in somebody got their mic on. In a very simple definition, I'm not talking about what is in the policy wording, but flooding is basically for laymen and for all of us simple people, means that flooding is where water is not supposed to be. And second definition is water at the wrong place at the wrong time. That's called flooding. So when the rainwater comes down in the agricultural field, it's a good thing. But when too much comes down, like China now, it becomes a flooding issue. And this is where flooding, the simple idea, is too much water. So what are the types of flooding that we see? It's due to heavy rain, inadequate drainage that cause a lot of flash floods in our context in Malaysia, tropical storms, so can be typhoon, hurricane that brings a lot of storm surge as well. There's also failure of protective devices, failure of dams, disused pools, agricultural ponds. There's also high tide, like I mentioned earlier. And only one mechanism of flooding that in Malaysia we don't get is the melting of snow. So, but all other forms of flooding, we do get it depending on where you are in Malaysia. So there are various strategies that are formulated and put into place for flood mitigation. So naturally, if you raise the building high, everything is built high, then you're out of the flood zone. So ideally, some insurance company will say build it above the 500-year flood level. Then you can actually provide building barriers, as what's shown in the bottom left picture there. So this is an industrial park, like in Thailand, they build a flood wall. You can see how inconvenient the cars to go up the ramp, just to stay dry. Then there's, of course, what people are very familiar, the temporary measures, putting in sandbags and putting up different types of flood barriers. Now you can see the sandbag right in the middle picture, bottom there, the Abatement there is not very happy because when the flood is gone, who's going to remove all the sandbags in front of his house? So it's a bit inconvenient when you have temporary strategies sometimes like that. Then you can have emergency response to complement those permanent or temporary measures. So it can be, like see those pictures, it can be flexible structures to sometimes more rigid protection devices. Now, flood strategies, it can be area-wide protection, like a big flood barriers. It can be also various retention ponds and underground structures to hold water, like the bottom left picture, it's our smart tunnel, and in conjunction with other retaining systems that protects the metropolitan KL. Then you can have also localized flood strategies to protect a portion of a town with flood barriers, like the pictures in the middle, or you can have specific protection. So like protect a basement for a house, or even to protect the entrances of some specific buildings. But in any flood strategy, you always must look at the practicality. So for example, somebody built a bund around their house. That's good. But you need to drive in, right? You don't want to climb a wall every single day you get in and out of your property. So when you have an entrance, you do not protect that entrance, eventually the property is going to get flooded. So likewise, if you have a house, you say, I can put in sandbags. There is a limit of how much you can do with a sandbag because, like I said, after the flooding, what do you do with all that sandbag? It's going to be left around the property. Then you can have more permanent sort of flood barriers. So like the one at the bottom right, so these are demountable planks, as they call in the industry. So these planks are protecting the electrical switch yard. And if they want to do maintenance, these metal pieces can be removed. So the strategy has to be correct for the object that is being protected. Now, is it that difficult? Well, surprisingly, sometimes even when I talk to my fellow engineers in IEM, engineers tend to over-engineer the solution. But it's not the case because water follows a very basic principle. Water always flows downhill due to gravity. And it always try to take the path of least resistance. So if the solution can be found to divert or block the water, that's great. Now, the bad news is that if the water gets into any space, fluid mechanics kicks in and it says that it will move together, right? And it will fill the space. So it gets bad news because if you have an underground space, even you have a very small opening, you do not protect that, the water is going to eventually flood the whole basement. That's what you see in some of the earlier pictures. So underground subway stations get flooded quite badly because water gets in through the staircase, and not only do you damage the building, you will damage all infrastructure within the tunnel as well. So that is why below grade space, especially from insurance perspective, is given a lot of attention because clearly it is below ground. So rainwater, flood water is going to come from the ground. So when this water gets into that space, cause a lot of damage to the building because, as we know, ground floor is a premium. So by design, architects like to push utilities and everything down to the basement, including car parks. And in today's world, many customers would actually use those underground spaces as storage as well, for their archive, for the unused furnitures, like in the hotels, F&B business, they always have that sort of storage in below ground space. Now, when you have below ground space, there's a lot of potential where the water can seep through. So like you can see in that picture on the bottom right, you have cracks, floor drains, you have openings for fresh air. So all these are potential spots where water is going to seep in. So as the overall basement and below grade protection strategy, we need to look at how you prevent the water from getting through those openings, the windows, the ramps, the doorways, and even any sewage pipes that may be connecting from the building out to the public system. And lastly, as shown in the left picture there, you need a pump to remove water that is falling from the sky, because we know in most cases flooding happens during heavy rain. So if you build yourself as a big fortress, you do not remove the water that's coming from the sky, eventually after a few hours or days, you will get localized flooding. So that's why a pumping system is important. So these are the overall strategy of flood protection. So you need a perimeter barrier. So this can be permanent or temporary, and this will keep the water out of the building. So it's designed such a way that it should be sealed together with the building structure or the building opening, meaning doorways, ramps that you may have for car parks. Then you have opening barriers. So this is specific protection that is put in place in those openings. Then you have backflow preventers. So the backflow preventers here, the purpose is to prevent the backflow from sewage pipes, even from the drain itself. Because, like I said earlier, water flows downhill by gravity. Now, if the outside area is already flooded by 1 meter high of water, the water is going to push back through the longkang and flood the building. So therefore, you need to have some sort of backflow preventer, sometimes even on the drain outlets. And then finally, the pumps itself, because the pumps needs to remove all that water that's seeping through all these flood abatement equipment. So why are we so concerned about flood water? Because people always see videos, when East Coast is flooding and they see kids swimming in the water and they think, hey, that's great, I can play in the water, right? But we know anything that flood water is not clean. It has mud, it has sand, stone, effluents. That means sewage. We have chemicals, because if you have upstream from the plant, you have a chemical plant, you have a palm oil plant, they use oils, they have chemicals, all these will be floating down with the flood water. There's also floating objects, as you can see. Flood water wash trees and whatever that's left on the side of the road. These will become objects that is moving together with the water. You have, again, animals that is inside there. It could be snakes, cockroaches, anything else. And flood water, as you can see, is anything but calm. It's moving. It has velocity and it's a head pressure. And what do I mean by that? So in a very simple sense, velocity can come from something that's moving inside the water or the water moving itself. That's why it's a big concern. And the head is the pressure that's exerted by the water, meaning the more deeper the water is, the higher the pressure is going to exert at the bottom. Now, I'm not going to go through too much more technical information, but this video can give you an understanding of why is it a concern. You can have still flood water for a while, but you always get that gung-ho hero who wants to drive through the water. And you can see when a bus, a truck drives through the water, is going to displace the water and create a wave. So this wave is the one that very often flood barriers may not be engineered against. So that is why the performance of a flood abatement equipment is to keep the water out in the flooding situation. Because as we know, the flood barrier is only as strong as the weakest link. So just like the picture of the Dutch boy there, you have a very strong built dike. But if you have a little hole that erodes the flood barrier, eventually it will flood the town. And that's the story of the little Dutch boy. So if you have a flood barrier that is not built in the correct manner, and a boat pass by it and cause a wave and break it, what's going to happen to the building? It's going to flood it. So that's why IAM created an initiative to come out with this guideline for performance requirement of flood abatement equipment. So we initiated these guidelines in November 2018, and it's in order to fulfill a need of the industry, because we see there is a gap currently in Malaysia that there is no specific standard talking about how you are supposed to build such an equipment, the manufacturer to build an equipment, how they're going to install it, and most importantly, who tests it. And finally, how do people, survey engineers, will give credit to it. Now, why do I say this? Because in my daily work, I don't work full-time for IAM. I do a lot of engineering survey, as what surveys in your company do. I write reports on behalf of many reinsurance companies. So when we encounter case of somebody DIY a flood barrier, we can't give credit to it. So that is why there's a need in the industry to come out with something that can be meeting a certain standard and can be credited for that purpose. So we set about having a few technical working group discussions, and we finalized that document in April 2019, and that document was finally approved by PIAM Council in October last year. So you'll be wondering, what is the purpose of having such a tested equipment? So it's for trying to create a uniform standard so that engineers can use the specification without repeating it again and again. So for end users, they know that this equipment has gone through rigorous testing and it will meet the performance requirement. Likewise, for contractors, they know that they don't have to engineer the requirement from scratch because it's already meeting some standard. And lastly, for people like authority and insurance companies, you know that if this is meeting this particular guideline, you don't have to go back to scratch and reassess, is it going to do the job? Is it going to stand the wave? Is it going to perform? So when we set up the committee in a working group committee in November last year, we actually have people from different agencies, people from government agencies, the regulators, professional bodies, and also a representative from PIAM itself. So I'd like to take this opportunity to recognize, some of the contributing members from PIAM itself. From Aptica, we have representation from Cairo Anha. From Lompek, it was represented by Hasno Zamri. Progressive Insurance, we have Rizwan Ahmad. RHB, Mr. Ng Sikai. And lastly, from Zurich, we have Tunku Shaifuddin. So a lot of the members, especially the representation from PIAM, we were very thankful because they gave a lot of good challenging, as to why we use certain parameters for the standards. And we also have input as to what is the test that is required to meet the performance. So out of that, we have actually grouped it into 3 broad groups. And within these 3 broad groups, some of these will be what we call as required mandatory tests. So hydrostatic, that means how high the water the barrier can withstand, is an important factor. So a certified, say, 1 meter height barrier is only good for installation of 1 meter. And likewise, there is a certain performance criteria for wave and also current, that means the water flowing in front of it. So these are the 3 mandatory requirements to meet as certified flood abatement equipment. Then there are specific component tests. So like you can see in the middle picture there, some cases people just DIY the hinge, and after a few cycles, this breaks. So these are the issues that we do not want to see in something that we want to give credit for flood abatement. So there's rigorous testing on cycle durability. There's also salt spray requirement if this is not made from steel. So if it's aluminium composite, this would be a concern. The tensile strength and accelerating aging if this has rubber components in them. So these are the tests that will apply based on the component of the construction. And then there's also optional tests that can be very rigorous. So this will be very specific application if these are these are used in non-household or non-industrial applications. So if you're going to use it for an area-wide protection, then overtopping is a concern. Overtopping means is the flood water that is slightly higher than its height. You don't want it to collapse catastrophically. And some of them are very rigorous, like a debris impact. So you tembak a balak, a big log onto it, it will not break. So for East Coast sort of condition, like those in Kola Krai, a debris impact will be applicable if you're building a flood barrier there. So I'm not going to go through the technical detail because I can talk half a day on this. Now, more importantly is equipment documentation. So in this particular guideline, we spell out very clearly what are the guidelines documentation that is needed in the guideline. So the manufacturer needs to state clearly what is the deployment time. Now, if the flood barrier takes 2 days to install and the flood warning is only 1 day, it's as good as none. So the deployment time becomes important because, as surveyors, when you go down to site, you look at the equipment and they say, I need so much manpower, but they don't have the manpower and the tools to install the flood barrier. How do you debate with them? But if the documentation says you need 2%, it can be deployed in 3 hours, and these are the tools required, that's fine. That's how we can give credit to it. So the tools, everything, if it's a complicated system, should be documented so that the end users have those equipment in hand. Now coming just to the last few slides here, we also included some appendixes in the standard itself. Appendix A is talking about the testing facility. B is talking about how to design. C is the climate change factor. I mean, we are all very concerned about the climate change. And most importantly, like the contribution from the PIAM members, is Appendix F. I mean, this is put together for engineers and also manufacturers' point of view, because they always ask, what is the insurance impact if you do not have protection? But again, to qualify this, if you get it from email later, from the PIAM secretariat here, this flood insurance was pre-tariff days. So if there's update information from PIAM, we are welcome to give it to us, and then we will update the Appendix F in the next release as well. Because like I said, this is pre-tariff days information. So this is NARIM. They have actually a full-scale testing facility in Sri Kembangan. So as part of the working group, we actually paid a visit to NARIM and look at their facility. So Malaysia, we actually have facility to able to test such equipment if the manufacturer is interested. So this is the guideline that is published by the Department of Irrigation Malaysia. It actually talks about what is the design requirement for underground basement car parks. So we are just putting it into a document as reference because, like I said, this is not a design document. Somebody has already come up with the numbers. We also provide background information on climate change factor, referencing the documents that engineers or manufacturers can use. We will explain the concept of return period, but I believe for this group of audience here, I don't need to present this because we have underwriters and surveyors that is very well versed in this. So our main concern why we put this standard is flood barriers failure, because flood barrier failures affects everybody, the community, the person, the family, and ultimately, if it's an insured property, the insurance people will have to pay for the loss. So we want the flood barriers to be credited when it is meeting a certain standard. So lastly, as a summary of what I talked about, flood can be predicted and mitigated in most cases. So there are very varied and many different engineering measures that's been put into place. So there are many flood solutions that can be put into place to mitigate and limit the flood damage. But having product conformance and certification will give end users, a good sound of mind that, hey, this has been tested and verified by third party. Because if you go around, you can see a lot of do-it-yourself sort of flood barriers, that may not meet the job and giving a false sense of hope to people. So that's all the session I have. So the next portion will be taken over by Engineer Kim.
Hello. Oh, good. Yeah. So, my name is Kim. Good morning. I'm going to share with you today on the flood protection equipment. Like just now, we talked about the flood barrier. So, when come to testing standard, just now, Engineer Lu have already explained to you all. Now, how to apply it to the property? That is the application issue. So we want to explore how we use it effectively to protect the properties. So there are various engineering design and importance of hardware and software as well. What we mean by software? Software is a person, is a program that make the flood abatement equipment become useful and effective. So let's take a case study. For example, this is a typical layout of a plant. So if we look at the plant, we know this is a potential flooding area. What can we do with it? So what we normally do is we analyze the place. This is an outer barrier. This is a building barrier. So we put it into two different what they call perspective. First, we look at outer layer. Water can come in from the entrance. Water can come in from the drainage. Water can come in from the doors and window. For the inner layer, water can come in from the building entrance, distribution box, window and vents, drainage, and toilet. So these are the possible area where water can come in. So what we can do, we take care of the drainage by having a sluice gate, driveway, we have the floodgate, doors, we can add a catchment basin. For inner building, we can have a distribution box where we have some foam to seal it off. With entrance, we can add a floodgate. Drainage, we cover it up. Toilet, entrance, vent and window. So these are the things that we can seal off during the flood time. So when we want to apply that, we have to look out for whether the wall, the strength of wall is sufficient to take care of the hydrostatic pressure or not. Not only the equipment itself, because if you build a strong equipment but the wall cannot withstand, the whole thing will collapse. Look at the cracks and hole on the wall, pipes and drainage, and then make sure that we have a pump where pump the excess water out from the building to outside the barrier. Then if puddle of rain indoor, catch basin and water pumps in the factory. So we have to drive the water, pump the water out from the factory itself. And then some other connecting pipes like the stopcock drain cover pipes is good to have it to stop the water from flowing in. And then for the ground pipes, we can apply the foam, the sealing foam to seal it off. So typical building, when we look at 2D, on the vertical side, so we can see if there is a basement. So what we can do, we can have the window, we can have the floodgate at the entrance, underground car park, driveway, the hatch door, safety hatch from here, and this one, non-return valve. Then planning for normal houses which you don't have a underground area, then it's very simple. It's rather simple. Then if you are dealing with a factory or a warehouse, you have a big roller shutter. So the other things that we should consider is to whether to keep the floodgate before or after the roller shutter. So there are some pros and cons. The best we recommend is to have it this outside the rainwater, then only inside you have the floodgate. So what happens is the roller shutter can help to prevent the splashing of rainwater. Whereas if we put the floodgate in front, okay, in front of the roller shutter, so chances are rainwater go through, pass through the floodgate, and some water still seep through the roller shutter. So this is something that we can look into the fine detail when we want to do a flood planning. Certification test. I have some documentation of what the real tests have been done. So, like the window, the impact test is done like this. For the sluice gate, the impact test is done like this, and the demountable floodgate, the impact test is done like this. Static water pressure test. The water is filled up to the max, and then let's see after an hour or 24 hours or 48 hours, how much water seep through the gap in between. So this is how the test is being done. Let me show you some of the real case scenario that how the test is being done. This is done by FM Global Test Standard people. So when we want to do a test, the inspector will witness how the things being assembled, whether it is repetitive or not, it can be reused or not, and then how much time it takes to fix it up. Then here, we discharge the water.
Kim, can you show full screen? You are showing your slide screen is not very clear.
Sorry?
You selected the wrong screen for the presentation. Can you switch the screen?
Yeah. How to do it? Let me see. You are not seeing the video? Are you all seeing the video?
No, not at the moment. The pictures, but not the video.
Okay, how to share the video?
If you're working with two screens, you need to switch the presentation screen.
Oh yeah, I'm working with two screens. So I should share, I should get the screen two, right? You all see the video now?
Yes, it's full screen now.
Okay, sorry, share the wrong screen. I restart the video. So this is a test done in the witness of FM Global. It's an international company. They are also having the flood abatement standard. So when they inspect and giving the accreditation, so they want to make sure that the things can be done repetitively. So this is a hydrodynamic a wave test. Create the wave and make sure that the flood barrier still can withstand the wave pressure. This is the current. The site created a fast water by a pump, simulate the current. Hydrostatic test. And then this is the impact test being done. After the impact test, still cannot have water leak through. So that's how the certification is being done. Then when it comes to application, so that is a design where we want to apply on which part of building. That depend on the creativity of the designer. So you can be at the doorway, you can be at the rearway, you can be at the wall extension, you add up, top up to the wall, as a window, riverbank, driveway, entrance. So that depends on the design application. So it have countless. You can do it yourself. The next one is a component design. We want to understand how each part, each component works. So you see, we have a base plate. Base plate here is to make sure that the gap is sealed properly, and it's made of stainless steel. And we have a side post to anchor and to give pressure to the plank. And then that is a plank. The plank is very, very lightweight. It has a stiffening ring in between, only 4. And then all this rubber is EPDM. It's a weather resistant rubber. Then when we want to install it at a very wide area, we need to have a middle post. And then we have a back support to counter the pressure from the water. And then this is the basis to lock the pole, the post. Tightening ring is to put the pressure down to the plank so that it can secure the seal. So this video will show you how it theoretically works. This is a very simple video done by a Japanese, explain how it works. This is a tightening nut to press the plank down. So we give you some idea how it's being applied throughout the world. This is Hong Kong, this is a Macau Fisherman Wharf, China nuclear plant to protect their facility, Japan on semiconductor, the hospital in Indonesia, Thailand University, Philippines, Vietnam. Okay. When we come to this flood abatement, actually it is very important to have the software in place as well. That's why on-site drill and training is an integral part of the program. This is very important. If you put something and then people don't know how to use, or when you want to use it, it cannot be used, this is equal to none. So training is very important. Then flood doesn't happen every day. So when you want to do it, sometimes you forgot. Then training poster is important to refresh the mind of the operator. And then video. We also provide videos for the users where to remind them, or they do the yearly or half-yearly trainings, so that they do it again and again, then it will go into their minds. And then you don't get panic during the flood. If you look at the whole process, for this size, it will take less than 3 minutes to fit everything.
Enter your access code or meeting number followed by pound. Enter your attendee ID or the start meeting passport.
Some successful case study for you all. These are the photos given by the user. 2006, 2007, 2008, 2009, 2010. You see, this is a white plate, and this is a white plate. So proper installation is very, very important. This is Macau to protect their leaf. This is happened only last year. So outside is full of water, but inside the building is totally dry. This happened only this year, 1st of January in Indonesia. And this one happened in May, few months ago. So other this technology, again, we just now talk about, it depends on creativity of the designer. So you can have a different one, a simpler one with a low level flood. The window, the sluice gate, water hatch door, watertight door, swing gate, electrical hydraulic barrier. So let's say you want to make everything automatic. You can install a sensor at the lower ground area. When the sensor is deep inside the water, the gate will lift up itself. So you don't need anyone to operate the gate. It's fully automatic. Summary, flood abatement application is a comprehensive program, not a product by itself. So a program consists of hardware and software. So flood abatement effectiveness very much depend on the competency and creativity of the applicator and the building itself. Because different design, you can use different way of protecting it. Then understanding every product have the strength and limitation, and apply to the right condition is very crucial. And periodical training and maintenance to ensure the effectiveness of the program. So thank you, and we just would like to extend our gratitude to Daichen because it provides us all the technical information and their experience. So here I end my session. We pass it back to Mr. William.
Yeah, thank you, Engineer Kim. So now we would like to open the floor for questions. If you have any questions for Engineer Kim or Engineer Lu, please feel free to use the chat box. So far, do we have any questions in the chat box? Or if you prefer to ask, probably you can unmute and ask question now. Anyone? Okay, if there is no question, I'm sure we once again would like to thank IEM, particularly Engineer Kim and Engineer Lu. I'm sure we all benefited from the new insights into the type of flood abatement equipment. We have seen a lot of different type of equipment today, the standards, certification, tests involved. So should you have any further question, you can channel it to the Secretariat and we will forward it to both speakers, and we'll get back to you with the answers later on. So,
Mr. William, I think Tengku Saifuddin have some question to ask, but he cannot unmute himself.
Okay. So, Shafa, are you there, Shafa? Shafa?
Oh, okay.
Okay. Yeah, go ahead, Tengku.
Can you hear me?
Just now can hear, now cannot.
Yeah, I think it's okay now. Tengku, go ahead, please. Okay, we have a question in the chat box. Are there any local supplier for those flood abatement devices? What are the ballpark figures? Engineer Kim, can you hear me?
Oh yeah, I can hear you.
There is a question. Are there any local supplier for those flood abatement devices? What are the ballpark figures?
So far as IEM concerned, we have done the market survey and we cannot find any manufacturer in Malaysia having a floodgate that meet these certification standards where fulfilling IEM guideline. So only overseas, and then the ballpark figure we really don't have because every design is different and is unique. So have to look at the location, then only can give the ideas actually how it's being done, and the figures can come out from there.
Okay. How about any recommendation on suppliers, potential suppliers? of this other than the one that you mentioned in your presentation earlier?
For this standard, as far as we understand and we check around the world, for FM standard, there are three manufacturers in the world. Two is in US, one in Taiwan. So the idea of IEM having this guideline is to introduce and localize the standard to Malaysian environment and make it available for everyone so that a Malaysian also can start doing themselves if they want.
Okay, point noted. What do you suggest, assuming that, let's say, underwriters, when they propose this flood abatement equipment to their client, so I'm sure they may need some recommendations or advice for how to go about it. So can our members approach IEM on this?
IEM, from the DRAB, we will give some recommendation, but then that is from engineer point of view. So we will give some ideas like our slide, we do some research and then we give some ideas how to solve a problem.
Okay,
but
yeah.
Eventually, the customer have to determine what type and who.
Of course,
okay.
yes. Yeah.
Yeah. Of course, we feel we will give our best recommendation to them.
Okay. Yeah. So we have some questions here. How about Tengku? Are you able to speak now, Tengku? Hello?
Yes, can you hear me?
Yeah, we can hear you loud and clear. Go ahead, please.
Great. Yeah. Well, I find this presentation very lively and very informative. But just one question. If I have a customer right now who's interested to install a flood barrier, who should I approach? Should I approach IEM, or is there a specific consultant who can come up with a design and provide a quote? That was my question.
Hi, morning, Tengku. Allow me to answer that question. In order to get a comprehensive design, as what Kim was explaining in his part, the customer direct should actually appoint an engineer or a licensed surveyor. That means basically like a civil engineer or quantity surveyor to advise them, because it is not a matter of just going out there and buy the barrier and put it there, because number one, as you know, somebody needs to do the flood study for that area and determine where is the source of flooding coming from. And number two will be how high the water is going to be, because whether is it half a meter or 1 meter makes a big difference. So, and then the more important question would be that the engineer can pick a number and says, well, it's half a meter based on a 50-year flood occurring, or 100-year occurring based on a MASMAS standard. That means the Malaysia Stormwater Guidelines. The guidelines presented by DID is also based on 100-year plus a freeboard of 0.6 meter. Now, this is where the PIAM members needs to be coming together and try and fill the gap. Designing to 100-year, is it adequate? Because as you know, some reinsurance company, the international ones, ask for 250-year occurrence, 500-year occurrence. So the reservation here, I have to say, is that if the local consultants are not aware and they design it for 50-year flood, the barrier is only good for 50 years. And we write it up in a report as 50 years. When this goes to the market, they will say it's not good enough because they want a higher flood and so flood protection level. So if the freeboard is very minimal, they do not even have the 0.6 meter freeboard, then the flood barrier is just considered as none. So there's multiple parties that needs to provide a lot more data before a design can be finalized, And again, which system they choose as Kim showed towards the end, there's a automatic system, there is manual systems. So whether automatic or manual, it depending on the appetite of the client. Because I've seen some installations where it's a high-end condo in some countries. They say, I don't want the building management to touch the button. They want it to be automatic. And it's fully automated. They pay a lot of money because all the cars in the basement is very, very expensive. So unfortunately, the question is short, but the answer is very technical, and a lot of parties needs to provide their input as to what is the appetite to basically mitigate the risk.
Thank you, Lou. I think what we should do as insurers now is to advise our customers that there is now a guide, a Malaysian guide on flood protection system equipment, and I think they should have a copy of this guide. So as someone asked just now, where can we get this guide? Is it readily available?
Currently, we are making this available for distribution. So we already submitted the copy of this guideline to PIAM Secretariat. So I believe William should be finding a way to post it to the members. Even in other organizations that we have spoken with, like the ASEAN engineers, it's distributed now to the regional as well. So, and hopefully we can collaborate better with our neighboring countries and have, products that are made in the region, if not made in Malaysia, available soon.
Oh,
Yeah.
just is it?
Sorry?
I'm just wondering how many pages is the guide? Roughly, if you can tell me. Is it a very thick guide?
In total, it's only 26 pages.
Oh, okay, thanks. Thank you.
So probably what we will do is that we will make available the guide on our website together with the presentation slides, so that you can download it from there. So is that okay with everyone? Okay, now we move on. I see some questions here. What is the suggested flow rate discharge for dewatering pump? Let's say 60 millimeters rainfall for 1 hour.
Okay, I didn't manage to get into that section too much, but to answer this quickly, basically when you size for the flood water removal pump, like I said, you have to account for, number one, the rainwater that's going to drop from the sky. So then you have to account for the area that you are putting up this barrier. So can you imagine a 1 acre house compared to a 10-acre industrial factory? It is 10 times more. So the rainwater that's coming down is going to be, number one, it's not consistent, but you need to design for the worst case. So like in this case, if you're picking 60 millimeters of water per hour, you need to multiply by the total area of your catchment, as we call it technically. That means what is the boundary of this flood barrier? So you have to account for that amount of water that is dropping, whether in the front or the back of the building, is going to flow to your pump. Number two, you have to account for all the seepage or water that is going to come through the flood wall due to cracks, due to coming from the foundation and whatnot. And number three, you need to account for any further water that may be generated within the plant. So
喂，你叫阿 Priya 做嗰隻邊鬼個嘅？
我個 agent 嚟嘅，佢個 customer Abatement agent 嚟嘅。
同佢講做36,000啦，如果係。
Hello. Can we request those who are not speaking to mute your microphone? Thank you.
Yep. So the third one will be any water that the plant itself could be generating, especially industrial plants. So if their operation is still running and the backflow preventer closed off the longkang, so their wastewater cannot discharge to the river or to the drain or to the sewage system. So all this water needs to be accounted for by the pump system, and all this water from the rain, from the seepage, from the process itself needs to be removed simultaneously. So again, you probably need a process guy or engineer to do the calculation for the pump, of course with safety factor as well, you see.
Okay, we'll move on to the next question. What material is a floodgate made of? Fully stainless steel? Only stainless steel? What is the actual material specs? And yes, where can we get a copy of this? Guidelines from PIAM or DID.
In our guideline, we don't really specify what material to be used for, but we specify the requirement to meet the situation. For example, you are designing for meeting the standard of under the sun, you can up to how many years, and then for under the water, how long it can withstand, and it still maintain its integrity. So the choice of material is no limit. They can use as good as the what you call duplex metal, but then if you choose mass steel, more likely than not, the material will be corroded before you want to put it into good use. So material is not specified directly to that. It depends on the creativity of the designer.
Yeah, thank you, Engineer Kim. The next question, does the guide or the tools cater for different risk location on the flood map and elevation?
Yeah, if I can answer this, again, our standard do not have any design guidelines per se. We are only having the criteria to have certifiable flood abatement equipment. So in order to obtain the flood maps and elevation, then you need to go back to the current tools that's available in the industry. So IEM, we do not have any tools, and this tool is not being discussed in this guideline as well, because this guideline is talking about the end product. That means the flood barriers itself for a particular site. There's no design guidelines in this particular standard. So for flood maps and all those, you need to refer back to other tools that may be out there in the industry now, So like CatNet from Swiss Re or Munich Re,
Okay, thank you, Engineer Lu. So if there is a last question probably for both speakers. Do we have a last question for both speakers? Okay, if not, then we have come to an end of today's session. And of course, once again, we would like to thank Engineer Lu and Engineer Kim and IEM for making this possible. And there will be more such webinar coming up, and we'll keep all members informed on this. So with that, thank you for participation. Okay, thank you, and see you, everyone.
Thank you very much.
Thank you, everyone.
Thank you. Thank you.
Thank you. Bye.
Thank you.